Hello everybody. In this video, we are going to solve a problem from Fundamentals of Electric Circuits by Alexander and Sadiku 6th edition. It is practice problem 6.3 and we are asked to determine the voltage across the capacitor. So the question is the current through a 100 microfarad capacitor is I of t that is equal to 50 sine 120 pi t milliamps. Calculate the voltage across it at t equal to 1 milliseconds and t equal to 5 milliseconds. Take V of 0 is equal to 0. So the answer is given. We are asked to find the voltage V of t across the capacitor and the data given is C is equal to 100 microfarad, I of t is equal to 50 sine 120 pi t milliamps, V of 0 is equal to 0. So what is the formula to use? V of t is equal to 1 by C integral t naught to t I of tau d tau plus V of t0. This is formula number 6. So at t equal to 1 milliseconds, V of 0 is equal to 0. We are going to use this particular sixth formula. Okay, now we'll solve this problem. So this V of t is equal to 1 by 100 microfarad. So it is 10 power minus 6. Integral t naught is 0 and t is equal to 1 milliseconds. And this current is 50 sine 120 pi t milliamperes, isn't it? So it is 10 power minus 3 dt plus this v of 0 is 0. So this is equal to 1 by 10 power minus 4 and this 50 and this 10 power minus 3 are constant, so they can be taken outside. So 50 into 10 power minus 3 and then the integral of sine 120 pi t dt is minus cos. So I'll take that minus sign outside. Minus cos of 120 pi t divided by 120 pi, isn't it? With the limit 0 to 1 millisecond. So here this 10 power minus 3 and here 10 power minus 3 can cancel. So here you will be getting 10 power minus 1, isn't it? So that 10 power minus 1 can be brought to the numerator so that you will get it as 10. And then this 0 and this 10 can be cancelled out. So it is 50 minus 12 pi. Then here you have this cos 120 pi t with the limit 0 to 1 milliseconds. So this is equal to, so this value is minus 1.326. Then we apply the limits here. So cos of 120 pi into 10 power minus 3 for this 1 milliseconds. Okay, then minus cos of 0. So this is equal to minus 1.326 multiplied by 0.92977 minus cos 0 is 1, isn't it? So minus 1. So this is equal to minus 1.326 multiplied by minus 0.07023. So this is equal to 93.12 millivolts. So what's our answer? So the answer is V of t is equal to 93.12 millivolts. This is our answer. Similarly, we'll try to solve the problem for t is equal to 5 milliseconds. So the same thing is applicable. So V of t is equal to 1 by c integral t equal to 0 to t equal to 5 milliseconds. Here it is 50 sine 120 pi t milliamps, isn't it? So it is minus 3, then dt plus v of 0. V of 0 is given as 0 in the problem itself, right? So this V of t is equal to 1 by C values 100 microfarad. So it is 100 into 10 power minus 6. So this 50 and this 10 power minus 3 can be taken outside, and this integration is cos minus cos. So we'll take this minus outside. So these things are the same. 120 pi t divided by 120 pi plus this v of 0 is already 0. The limit here is 5 milliseconds and it is 0. So we already got for this as minus 1.326, but this cosine value changes, isn't it? Cos 120 pi into t value is 5 milliseconds. So it is 5 into 10 power minus 3 minus cos of 0. So this is equal to minus 1.326 multiplied by this value is minus 0.309 016 minus 1. So it is minus 1.326 and then multiplied by this minus 1.309016. So minus minus becomes plus. So this is equal to 1.7357. So this is our V of t in volts. So this is our answer. Okay, thank you. Hope you have understood.